so here we go. We have 42 grams of aluminum. Okay, notice it's in grams, okay, of aluminum. How many grams of magnesium chloride do you need for a complete reaction? And how many grams of aluminum chloride will you get as a result? Okay, so there's two different questions there. One is asking us to connect aluminum and magnesium chloride, and the other question is asking us to connect aluminum and aluminum chloride. So I'm going to do the first question first. I'm going to connect aluminum and magnesium chloride. So the first thing I do, I know it's in grams, but still, because I'm changing from one element to another, I'm changing from one molecule to another, I'm still going to start with my molar ratio. So aluminum in this was 2 aluminums. So 2 moles of aluminum. To the magnesium chloride, I need 3 moles of magnesium chloride. All right. Now, I write down what I'm starting with. I'm starting with 42 grams, no subscript, 42 grams of aluminum. All right. And I want to turn those 42 grams of aluminum into grams of magnesium chloride. So this is like what you would need in a lab, right? We know how many grams we have of one substance, and then we're going to use our knowledge and balancing of the equation to be able to figure out how much of the other substance do I need so that I'm not wasting any, so I don't have any extra left over. I can just hopefully do a clean reaction with the two things that are reacting. All right? This goes back to the original question we were talking about back in the lab that we did with the baking soda and the vinegar. How much do I need? Well, we could do that now. I just say, well, let me start with 50 grams of baking soda. Now, how much vinegar do I need? You could do that based off of this. So let's go ahead and do it. Now, because it's in grams, I can't use this yet. I can only use this with moles. So my first job is going to be to turn the grams of Al into moles of Al. Okay? Now to do that, we do need to go to our lovely table of elements, and we're going to need to find aluminum. There's aluminum right there. Okay? And if you find aluminum right there, you can see the number right there. The number is, hopefully you got your own there. The number is 26.982. Okay, so 26, we can write this over here. So 26.982 grams of aluminum is 1 mole of aluminum. All right, and this can be either way, doesn't matter, but those two go together, right? I can look that up on my table. Now, I do want to then take this and multiply it by my conversion factor, my conversion fraction, and I do want the grams of aluminum to cancel out. So when I look at this, I'm going to make sure that the grams are on the bottom. So I'm going to put the 26.982 grams of aluminum on the bottom, and then I put the 1 mole of aluminum up on the top. All right? And we see, as we have many times before, that the grams of aluminum cancels out, which means I've done it correctly. And then I'm going to go ahead and take my 42, multiply by 1, which is still 42, and then divide by 26.982. And I get 1.6. Again, your digits may be different. My calculator is automatically going to 3 digits here. So I'm going to have oops, I don't want red. Sorry, red. Red is my cancel. So 1.6 moles of aluminum. All right? So there we go. Now that it's in moles, now I can use my conversion factor, my mole ratio here, to turn it into magnesium chloride. So that's going to be my next step. So now I'm going to take this, my moles of Al, and I'm going to multiply it by my next conversion factor, which I want the moles of Al to cancel out. So how should I use my fraction? I want to put the moles of Al on the bottom so that my moles of Al cancels out. So I'm going to put the 2 moles of Al on the bottom. And I'm going to put the 3 moles of MgCl2 in on the top. All right, make sure that's clear for you there at home. And now I can solve. Okay, we see the moles of Al cancels out. Woohoo! And then 1.6 times 3 divided by 2, and we get 2.4 moles of MgCl2. All right, so we started with grams aluminum. We used one conversion fraction to turn it into moles of Al. Then we used our mole ratio to turn it from moles of Al into moles of magnesium chloride. And we're not quite done because the question is asking for how many grams of magnesium chloride. So now I'm going to use the grams of magnesium chloride. I'm going to do the same process. So now I need to go back to my table of elements. I need to find out what the molar mass of magnesium chloride is. So magnesium is 24.305. And then chlorine is 35.45. And there's 2 of those. So I'm going to add that on again. And I get 95.2. So that means that I have, actually let's use a different color here. So I have 95.2 grams of MgCl2 in 1 mole of MgCl2. Now you'll notice last night we weren't always putting the chemical on there. Now I am, because I do have moles to moles, which means I need to identify which moles of Al, moles of MgCl. I have grams and moles here. I have grams and moles there. Because I have lots more different grams and lots more different moles here, I am going to put the element or the molecule at the end each time so that it's clear to me which one I'm using at that point in time. All right. Now, this is my newest conversion factor over here. I am going to rewrite it because I'm running out of a little bit of space here. So I'm going to go again with that 2.4 moles of MgCl2. I'm going to multiply by the conversion factor. But again, I do want the moles of MgCl2 to cancel out. So actually it's good just the way that it is, right? I can put my 1 mole of MgCl2 on the bottom and then the 95.2 grams of MgCl2 on the top. And so then I can just go 95.2 times 2.4 and I get 228.5 grams of MgCl2. Ta-da! How about them apples? It's not apples, it's aluminum, right? But same idea, you get it. All right, awesome. Now, to be fair, for this question, that's only half the question, right? The question was how many grams of magnesium chloride do I need for a complete reaction? Well, now I know. Now I know. If I have 42 grams of aluminum, I scoop that in with my little scooper. Then I can take a different weigh boat. I can measure out 228.5 grams of magnesium chloride, and then I can dump those in together, and I get hopefully a clean reaction. Now, what we'll learn later on, not necessarily in this course, but as you go further in chemistry, you'll recognize that a lot of times these reactions go both ways. Sometimes they go one way completely, sometimes they go both ways. Sometimes they go to a point and there's such a high concentration that they stop reacting. There's a lot more to this, but again, just like with physics, we're looking at ideal situations here. Ideally, what would happen? Well, ideally, we would use up everything, it would all react, and we would end up with this. So for now, we're working with ideals, okay? Now, I am going to go ahead and show you the second part of this. I'm going to do it in a slightly different way, though, okay? So this time, it wants me to start with aluminum. I'm still starting with the aluminum, or I could do the MgCl. It doesn't matter, but I am going with aluminum. And then the question is, how many grams of aluminum chloride, okay? So, again, I'm going to go through the same process, but I'm going to do it a little bit differently. I'm going to show you how you can shorten the writing just a little bit, okay? Now, because of this, I'm actually going to use my red marker here so that it's distinguishable from what we have, all right? So I'm starting with 42 grams of aluminum. Okay. Now the first thing that we want to do is we want to turn those 42 grams of aluminum into moles of aluminum, which actually we've already done, right? But just for kicks, let me show you. I'm just going to go, okay, 1 mole of aluminum and then 26.982 grams of aluminum, right? So that is this conversion factor we use right there. So what this will do is this will cause my grams of aluminum to cancel out, and it will leave me with moles of aluminum. Now, rather than getting the answer and then doing the next step, I'm just going to do the next conversion, because now I'm in moles of aluminum, right? We already know that the next step is going to be to change the moles of aluminum to the moles of the other substance. Now, I am going to need a new conversion factor because now I'm going from aluminum to aluminum chloride. So in my equation here, I have 2 aluminums and 2 aluminum chlorides. So I'm going to go 2 moles of aluminum and 2 moles of aluminum chloride, right? That's from my equation right here. 2 of these, 2 of those. That's my molar ratio. Now I see the moles of aluminum on the top, so I want that to cancel out, so I'm going to put my moles of aluminum on the bottom. So I'm going to put 2 moles of AlCl3 on the top. I'm going to put 2 moles of aluminum on the bottom. So I skipped this intermediate step. I didn't actually find this number, but what you'll see is that the moles of aluminum and the moles of aluminum cancel out. All right? And so therefore, I've now canceled out the grams of aluminum, I've canceled out the moles of aluminum, and now I'm in moles of AlCl3. Now we know what the next step is going to be, right? We just did it up here. Now we know that once we have the moles of this, I'm now going to turn that into grams using that last fraction, that last conversion fraction, that last conversion factor, right? And so we're going to go, okay, times, now I need to figure out what the grams per mole of AlCl3 is. AlCl3. So again, I'm going to go to my table of elements, and I'm going to look it up. I'm going to say, well, Al is 26.982. And then I'm going to add the Cl, and the Cl is 35.45. Again, surprise, same thing as last time, Mr. Bywater. And I've got 3 of those because it's Cl3. And when I push enter, I get 133.3. All right? So what that means is that I'm going to write this over here. I got 133.3 grams of aluminum chloride is 1 mole of aluminum chloride. Okay, so that is the fraction. That's the same thing you were using last night and the previous night. So I'm going to go ahead and use that here. I've got moles of AlCl3 on the top, which means when I write my last conversion factor here, I want AlCl3 on the bottom, which it is. So I can put 1 mole of AlCl3 on the bottom and the 133.3 grams of AlCl3 on the top. Once again, we cancel out the units, moles of AlCl3 and moles of AlCl3, leaving us with, you'll notice that all the other units in the problem have canceled out, which means the only units I have left are the AlCl3. So we can still do this in a quicker manner. We can skip calculating each of those middle things as long as we pay attention to the units. Now, if this right here was just way too confusing for you, it's fine. Do this, right? Do one at a time. Do one, calculate the number. What happens next? Calculate the number. But if you're to the point where you can start thinking a little bit more in advance, you can do this, right? Do one, cancel out. This is what I'm left with. What's the next fraction? Cancel that one out. This is what I'm left with. Okay? What's the next one? cancel out. This is what I'm left with. So at this point, I just need to do the calculation. Again, we just multiply everything on the top. So I'm going to go 42 times 1. I don't really need to do the times 1. Times 2 times 133.3. And then I'm going to divide by anything on the bottom. So divide by 26.982. Divide by 2. And divide by 1. I don't need to worry about that. So I go enter and I get 207.5. Grams of AlCl3. All right?